Thank you, everybody, and welcome. Really great to see this show of support. So, I mean, obviously, everybody knows who I am, Steve Nerayoff. But I'm excited because we've got these two up-and-coming hackers that I am predicting are going to do some big things in this space. And I'd like to introduce you to Vitalik and Vlad. So, Vitalik, it's been a little about 5 years since we all came together, and you did some pretty great things that I think everybody knows about. And our relationship was amazing. We were roommates, would you say? And some interesting stories here, people. I was at the table, if you don't mind me saying this, and he was typing, and I asked him what he was doing because he was also looking at a book, and he said he was coding, and I said, "What's that book?" And he said, "I'm learning Mandarin." So he was doing both at the same time. I remember it. But your friendship has already become legendary, and the partnership here, you guys are maybe the Bonnie and Clyde of blockchain. What's your relationship like? What do you guys talk about? Is it just math? Is it just code? You guys talk about chicks? Like, what do you guys talk about?
Yeah, crypto chicks. Yeah.
What do we talk about, V?
Well, I mean, I think we talk about tech stuff occasionally. We talk about governance stuff occasionally. We talk about logistics stuff occasionally.
Yeah, logistic stuff, yeah.
Yeah, like where are we going? Where are we meeting? What are the events?
And Vlad's habit of always making sure to come to every airport 5 hours in advance.
I don't remember this conversation topic. But, I'd say, I guess we mostly talk about work stuff, but I think mostly because that's what we are preoccupied with.
Mm-hmm.
How does that flow go? Do you request research? Do you give ideas to each other?
Well, we used to work on research together a lot more than we do now. Like, we used to talk about all of our research problems on a almost daily basis. And then, over the last couple of years, as our distributed systems research kind of went in other different directions, our conversations are more when we have critical problems, we get each other's feedbacks, and then when we have conversations around non-tech stuff too, but that's, I think, a little bit less. What we talk about. I don't know. V, what would you say?
It seems about accurate, yeah.
But we really do want to talk about tech stuff.
Mm-hmm. Well, the rest of the community is appreciative of the communication. And so on the tech stuff, there's a lot of talk about, centralized, decentralized, permissionless, permission. Getting to this essence of decentralization, why do you guys, in your own words, think it's so important and the ramifications of it?
It's a leaderless protocol, V.
Sorry, the question is the importance of decentralization?
Right.
It's a leaderless protocol. Well, I don't know. I think decentralization is important mostly for... there's a bunch of different angles, right? There's an economic angle where you have fewer counterparties and therefore less coordination costs, which should be good for people doing transactions and to reduce people's contracting costs and therefore maybe have an impact on industrial organization kind of stuff, as people find new ways to organize because of fewer intermediaries, because the protocols allow for new ways to organize. And then there's legal and political benefits and realities to decentralization, because now with blockchain protocols we can do things that would, because of our right to run software on our computers, which previously we weren't able to do with within our legal and political worlds. And so decentralization, I think, is massively liberating because it allows us to organize internationally without having to have things that are within the grips of any particular legal systems. And therefore, if like corporations capture legislatures, we don't need to have everything fail because of this kind of corporate/legal capture. And so, like, I think politically and legally, decentralization is quite liberating. Economically, I think it can reduce coordination costs. And maybe those are some reasons why it's important.
I guess the aspects I tend to focus on, one of them is this idea of building things that it's easier for other people to then build on top of because you don't have kind of trust issues around that. So even basically because if you build a decentralized thing, then other people can be much more confident that it's going to continue to exist in the long run. It's going to have exactly the same rules as it had before, and so on and so forth. Decentralization kind of as a strategy in the context of existing political and legal orders is definitely something that interests me too. And I wrote that article about liability as control on my blog a couple of weeks ago, so that's been one of the kind of ideas I've been thinking about. Control as liability very recently. So it's sometimes about kind of ensuring trust, sometimes about kind of coordination without accidentally empowering monopolies, sometimes about coordination while censorship resistance, aka avoiding other people's monopolies. Probably some of all of them.
Yeah, I mean, it definitely feels like protocols are more likely to survive than, a corporation, at least when it gets to a certain stage. Mm-hmm. Like, I think, Ethereum is going to outsurvive all the corporations in the Ethereum ecosystem. Bitcoin is going to outsurvive all the corporations in the Bitcoin ecosystem.
Uniswap's going to outsurvive Uniswap Inc.
Yeah, but somehow smaller blockchains maybe don't have the same.
Well, it depends, right? Because most of these random blockchains that people have come up with in 2013 and 14 and since then, they still exist, and okay, fine, they have $460,000 market caps, or sometimes $446 million, and they seem like zombies, but they're still floating around. As long as there's one node generating blocks, you get blocks. I mean, maybe they get easier to 51% attack, but there's definitely no permanent death the way there is a bankruptcy event for a company. And other reasons that's interesting is that if one of these projects kind of quote dies, other people can just come in and revive it. And we haven't seen enough of that before, but it will be really interesting to see more of that happen.
Yeah, adopt a dead coin.
Yeah. Mm-hmm. Yeah, you have a dead coin, and then you just mine it for a year or 2 years, and then you just use the money to develop it and turn it into some super awesome thing.
Definitely really easy to do.
Mm.
So continuing on this topic of decentralization. So Vlad, over a number of years ago, you had a pretty massive breakthrough. You called it, I think, Casper, the Friendly Ghost. And can you give us the origins? What's the origin of the name? What was your breakthrough? And I understand it's a set of protocols. And how does it differ from other proof of stake protocols?
Yeah, so Casper came from this idea of the friendly ghost, which came from two things. One of them is the ghost fork choice rule, which was initially developed for proof of work, and some incentive mechanism or incentive philosophy that we have around proof of stake, and giving people an incentive to cooperate, where if they engage in any kind of adversarial incentives, then they all lose money. So through lose-lose games, we can create these incentives to cooperate. And that's the friendly kind of part. And the ghost part has to do with the fork choice rule of this protocol, which kind of chooses out of a tree based on this ghost rule called the greedy, heaviest observed subtree. But Casper research kind of really started as like this economic proof of stake research, and then got into the distributed systems stuff after the name kind of arose. Because even though we were talking about Ghost, we weren't really doing like serious consensus protocol stuff. We were kind of just imagining that we could just modify proof of work without having to have a kind of different distributed systems approach.
Mm-hmm. Yeah, and so there's also these two kind of families of algorithms that get called Casper. One is Casper FFG, which is largely my own attempt at making something which is kind of inspired by traditional BFT consensus and PBFT and all these other algorithms, but kind of fits into a blockchain context and can be bolted onto blockchains more easily. And then the other one, which Vlad's been working on much more, is Casper CBC, which is interesting because it takes this like really fundamentally different path to achieving things like safety and liveness goals compared to the more traditional algorithms, and like it doesn't even have like hard 2/3 thresholds the same way things like PBFT does, and yet it actually does manage to achieve the goals that it does. So I think like that's it's the CBC side is something that definitely kind of came later, and kind of versions of it that are efficient enough didn't come in time for ETH 2.0 phase 0, but it's still something that's potentially even more powerful in the long term.
And we're still working on efficiency improvements, but the CBC Casper philosophy is that, or somehow, I guess let me talk about first, like the motivation. It was like, I was working on proof of stake and trying to come up with an incentive systems, for a distributed system that comes to consensus on like blocks or whatever. And I was frustrated both with the complexity of traditional consensus protocols, really kind of very difficult to understand and to modify, change. And also with some of their properties economically, like this in-protocol fault tolerance threshold Vitalik mentioned. Like in Bitcoin, you kind of choose how many confirmations to count. In a lot of these traditional protocols, they kind of insist that you have to wait, or that you insist that decisions are only safe when they tolerate 1/3 faults, and somehow they choose this 1/3 number for you. And I was like obsessed for a long time to try to come up with a solution where you don't have to choose the number in the protocol, but everyone can choose their own fault tolerance threshold in the same way that you choose your same confirmation count. And somehow I learned about this correct by construction methodology for consensus protocol design, for computer science, like engineering. I'm applied it to a basic message format and a basic notion of safety to come up with the core of the CBC Casper protocol, which is, like Vitalik says, like quite different than traditional protocols. It's a very, very large state space, but very simple to describe. Protocol states are sets of messages, and by receiving a message, you transition to new protocol states. It's a really very simple protocol. And I think that's, and I've been following this kind of correct by construction methodology and doing research based on like requirements first, and making sure that like I meet all of them. And so it's definitely taking longer to get to a complete specification that meets all the requirements than Vitalik took to come up with the phase 0 specs, for example.
Speaking of like taking longer and the path down, so there's CBC, Casper, and then you have FFG and the ETH 2.0 roadmap. Maybe you guys could just talk a little bit about, what is the roadmap? I mean, Vlad, you could start off. What's your roadmap? What do you see, happening over the next year or two? And then Vitalik, if you could do the same with ETH 2.0.
Sure. So in CBC Casper research, we have basically a bunch of problems. I mean, it's very similar actually to it's like the problems we have in the blockchain space. We have to make a scalable consensus protocol. It's like proof of stake, and it's like efficient, it's secure, it's live. secure in the sense that it's fault tolerant, and secure in the sense that it's an equilibrium to follow the protocol, and in the sense that it's a robust equilibrium to follow the protocol. And so we have some research to do and to complete to get to the point where the specifications are complete so we can implement this like scalable correct by construction consensus protocol. And so I think one thing that we're hoping to see is that the specifications come to a stage where we can just go and implement it without worrying about the specification changing, or without worrying that the stuff we're implementing is going to need to be re-implemented or redone. And so that's the main thing, is like, okay, we're hoping that the specifications will come to a close, and concurrently, we're hoping that implementations will be built and that people will deploy them and maintain them, and that we'll get to learn also from the systems running, not just from the formal math of it. So we have like a research roadmap, and then I guess the implementation roadmaps are separate, and I have less clarity about the implementation roadmaps than the research roadmap because I'm a researcher, but hopefully we can talk more about implementation soon.
Yeah, so on the Ethereum 2.0 side, it's split into kind of 4 phases, which are zero indexed because we're good computer scientists. So phase 0 is just launching a proof of stake chain. So it doesn't even support any kind of sharding, scalability, virtual machine, or pretty much any transactions except just running the consensus mechanism. And so the goal of this is to just get the chain running, make sure the proof of stake side works, get it out there. Phase 1 will introduce sharding, but focus on sharding of data and not focus on running smart contracts, or interpreting the data as transactions and any of those things. Then that will be introduced in phase 2, which will lead to a fully functional, scalable Ethereum system. And phase 3 and beyond is this catch-all for things that we want to do after. And the main things that we know we want to do, likely, one of them is potentially using things like Starks to improve scalability and do more verification. And another is to add Casper's CBC as a consensus algorithm for the Ethereum chain.
So in discussing your roadmaps, what do you, either one of you can take this or both, what do you see as like the key similarities between your two approaches and the key differences?
Well, I mean, the biggest similarities are like that we're trying to solve the same problem, and so there's a lot of similarities actually that arise because of that. Like we have, security deposit-based proof of stake. We're actually using very similar fork choice rule. We have a lot of actually similarities between the specifications that arise just from the fact that we're trying to solve almost the same problem, if not exactly the same problem. So there's a lot of kind of natural similarities. I think there's a lot more similarities in specifications and designs than in our approaches.
So, Vitalik, right now, Vlad is working on an implementation, possibly the first implementation of CBC Casper with the Casper Labs project. What are your thoughts about that, and how do you think is there possible ways to collaborate?
And I think it's definitely great to see that there's a project looking to start using CBC Casper and actually push it out onto some kind of live network. And I definitely think that the just standard for what passes as proof of stake just needs to be raised across the space, so we don't need to have as many networks run by 17 validators that are all in the same country with 11 of them run by the same company. The problem, so that's great, and I think it's also going to contribute because, look, even if the versions of CBC that Vlad would want to kind of move toward and say that we would be interested in for phase 3 of Ethereum 2.0 have their differences, like a lot of the core is very fundamentally similar, and so a lot of the infrastructure around just analyzing these algorithms, proving them, and improving their efficiency will end up being shared. And there's already some group people that are doing formal verification on CBC Casper, and I think the work definitely touches on both the versions.
So the teams could collaborate on the research. Excellent. I mean, it's so I mean, and speaking about your research, like you guys, there are problems in blockchain that unfortunately fall into your lap that you just have to solve. But then there are things that maybe like really just get you excited that you didn't have to solve, but you really want to solve. Like, what's on your research agenda that you got really excited about?
Outside of consensus, the other one is just like using mechanism design at the application layer. So this would include things like DAO design, like some of these token models for applications. Collusion resistance and mechanism design is also a really big and important thing that I've been focusing quite a bit on lately. Also, there's also like one of the other kind of things is kind of very concrete issues related to details of the Ethereum 2.0 design. So one example of this is just how to design the base layer for how the data in the Ethereum chain gets interpreted as transactions and how those transactions get executed. So we've come up with this very abstracted design that means that the amount of work that's left to that's done on consensus layer is quite limited, and like you do need a bit more extra layering on top, but the design allows you to have this really simple consensus layer where like phase 2 can just be defined in the spec in maybe a few hundred lines of code, which is really nice.
It's you know, a lot of people are saying mass adoption hasn't happened, blockchain isn't real, you know, these applications aren't going to happen, and so to date they haven't really taken off yet, and the industry is obviously very young. But in your opinion, like what is like the 1, 2, or 3 things that need to be solved for that to happen?
So 1 or 2, I would say, like we have scalability problems. We talked about a bit. You know, blockchains today don't really scale. It's kind of a problem. And also I think we have a lot of legal and political and governance issues in the blockchain space that I think are going to need to be addressed for people to have the like legal certainty required to have like this level of adoption of blockchain tech. If I had to pick 3, maybe also this like whole I lost my keys, therefore I lost my money problem. There's a lot of user experience issues in cryptocurrency associated with cryptography and humans. You know, that's like just hard to use in a way that's safe.
I'd throw privacy in there.
Yeah, that's actually a big one, and also is to me in that like 3rd category of like, you know, user experience and safety. Because like if you think your experience is private when really everyone gets to see everything, I mean, it's not a good, I mean, in some way it could be a good user experience, but it's not representative of the reality, and so it could end up being a really bad user experience.
Yeah, you've touched on a really important topic, and something I know, Vitalik, you've done a lot of research in, and it's the privacy. Like, why you know, when people say privacy means you're hiding something, you know, like, and why do we need to have privacy, you know, on the blockchain? It's all supposed to be open. You know, what do you respond to that?
I mean, in terms of why privacy is kind of philosophically important in general, I think it's because like if you're forced to live your life and do every action in your life as this kind of dual purpose thing, where one part is the actual purpose and the other part is some kind of performance to look good in front of society, then you're just going to not do well at either objective, and we end up with a society of very unhappy people. So I think maintaining privacy is definitely just really important to just limit people's ability to play these really destructive signaling games with each other and be forced to do that in every aspect of their lives. More concretely for blockchain applications, I think first of all, blockchain applications currently have like much lower levels of privacy than people are accustomed to. Like as Zuko says, it's like Twitter for your bank account. And there's already signs that people are kind of apprehensive about participating in some applications because of privacy. So there was this sort of hubbub about Humanity DAO about a week ago, and a lot of people did not want to participate in this thing because they basically did not want to attach their Twitter account to their Ethereum address. Because
that's why I didn't do it. I wanted to join the cool kids, but
Yeah, no, that's definitely, and the only reason I did is because the account I used just like links to me on Etherscan already, so I'm kind of screwed
that's
there.
smart. Yeah, I could have already.
Yeah. No, like if we had like even just something as simple as the thing I've been advocating recently, which is the easier infrastructure around having multiple accounts and around being able to just send ETH from one account to the other to pay for gas through some mixer without linking all the accounts to each other, that could be such a big step forward.
Yeah, I totally agree. I want to echo, especially agreement with the idea that we need to have privacy in order to prevent public law and politics, the way I'd say it, from having a jurisdiction everywhere in everyone's life. Like, you need to have some notion that some things are private in order to have some things that are kind of protected from the operation of public law and from public political discourse. It's really easy for something to be politicized once people pay attention to it, and it's really easy for people to bring conflict due to things that they can see. And so even if you don't have any adversaries today, in the future you might. And if you do believe you live in a world where we have political struggle and you have political opponents, then you do have adversaries, and that privacy is super important for your political mobility, your political ability to act. And so I think we want freedom of speech because we want to have the political mobility associated with freedom of speech, even when we have nothing to say. Mm-hmm. So even when we have nothing to hide, we don't know about any particular adversary. Like, we should want to preserve our privacy because in the future we might need it for our own individual or collective political and legal positions.
I mean, you're hitting on a really important topic: politics, law, society, and at the end of the day, those on a blockchain, it's its own society. And one of the areas, in my opinion, that is most infantile probably is governance. Mm-hmm. And how do these blockchains govern over time? Now, Vlad, I know you've taken a pretty harsh stance against the code is law, without any exceptions in every situation. Vitalik, you've been a little bit more practical about your approach to it, and I'm wondering, why do you think the way you do, and what do you think is necessary to get us to that next level of governance?
I guess, I don't know, I feel like the things I've said are more a response to the things Vlad said, so maybe Vlad talking first would make sense.
Yeah, sure. So, I started getting interested in law kind of naturally as a result of my interest in blockchain governance. And, I recognize that law is about disputes and about disputes that people actually have. And not just about the legislation, like codes of law, but about the actual disputes that people have. And I'm, thinking about principles of law and understanding that, the code is law, and specifically the cypherpunk immutability culture has really come about because of a radical distrust of law and politics, and a view that minimizing the use of law and politics is going to create more social scalability and more trustworthy systems. And just from a principled theoretical point of view, I had abstract from the blockchain governance, just from philosophy of law, philosophy of politics. It seems completely untenable position to me that we should completely radically reject and minimize the use of law in politics. And so from that just kind of abstract point of view, I came out with this against Szabo's law thing, which didn't really consider the realities of distributed systems and software in terms of what changes can we actually make, but was more about principles of law and more about what are our political and legal principles, and a rejection of this political and legal principle that we have that politics and law are bad and unworkable. And so that's what my Against Szabo's Law blog was about. I didn't really take it to this level where Vitalik did of what should we actually do. I was talking more about our principles, our philosophy. But I think I'm getting closer and closer to get practical. Slowly but surely.
Yeah, I guess my response to Vlad's post on Szabo's Law initially was basically okay, so we're not supposed to have an extreme cult of immutability. Well, let's try, let's try to actually think concretely about like at least what a world that moves one step in that direction would look like. And one of the immediate concerns I had is that it's difficult to use even when we recognize that problems from immutable blockchains exist, it's difficult to figure out how we would concretely use blockchain non-immutability as a remedy. So like I think a lot of people kind of got tricked by the DAO fork because it's a much more exceptional situation than a lot of people realize. And the DAO fork in many ways is this kind of really foundational event for a discourse about this whole topic. And like basically because what happened was that you had $150 million in a contract, then suddenly that contract got attacked. And it just so magically happens that the attack, it did not steal the funds. It also immediately, it also did not freeze the funds forever. It initiated this process that would then unlock the funds into the attacker's hands after a period of 35 days, leaving just exactly enough time for an interesting and protracted political debate to happen about what we should do. Right? And so that's what happened, and that's kind of what we got used to happening, but I definitely don't expect that to be representative of like future blockchain debacles. So like I expect most future blockchain debacles to either be funds getting stuck permanently or money getting stolen so quickly that it gets zipped around between different addresses to the point where we have no idea how to remedy the situation, even if we wanted to, except by reverting like all of history, which would also which I think would be even more unrealistic than the DAO fork. So I wanted to just get an idea of like what is even one example of a concrete kind of pro-interventionist attitude that could reasonably be seen to reduce harms from blockchains not being immutable without like breaking more other things. And I'm still continue to be kind of open to and looking for answers.
Yeah, and I mean, I think the kind of principles of law and politics philosophy conversation is kind of in some ways separate from the conversation of what remedies are actually available on a case-by-case basis. And I think it's also related because what remedies are actually available are going to really constrain what we can do with crypto law. Right? If crypto law is how we would deal with disputes in crypto, right now crypto law says like, not my problem, not my dispute, too bad, caveat emptor kind of story. And if we change that philosophy, we're still going to have to give that answer when there are no remedies actually available because of technical limitations. But there are going to be cases like stuck funds, for example, where the remedy is possible. And these are the cases where I think we might see a different outcome. Definitely cases where the remedy is not possible. I think immutability is de facto the law. It's kind of a natural law. Imagine, for example, if we had a completely zero knowledge blockchain and you couldn't interfere because we didn't have the information required to produce the zero knowledge proofs that would update the state correctly. Then it would be there would be nothing we could do with blockchain governance to remedy disputes that arise in the system. But in lots of cases, I think we're going to have maybe not quite something as nice as the DAO, but we do have, I think, lots of cases where remedies are possible through blockchain governance.
Right. Okay. So probably my two responses to that would be, one is that I don't see the discussion of principles and concrete actions as being separable in the same way, maybe because I have different principles about the relationship between principles and pragmatism. So what I mean is that I view principles as something which, they're ultimately Schelling points, right? These are things that are valuable, and there is value to these principles existing, and the fact that there is common knowledge that some principle exists and can't be easily broken is something that has a lot of value, but also definitely not infinite value in terms of just giving people certainty and protecting people from misuse of political processes. But and so the discussion of whether or not, or to what extent to weaken or move away from that principle, like often actually does depend on kind of very concrete on the ground facts about to what extent there do exist good consequences that could come out of doing such a thing. So yes, that's probably the first thing. In terms of like removing stuck funds, just as one example, and I definitely don't want to concentrate on the one example too much, but I'll concentrate on the example and the kind of broader principle behind it at the same time, which is kind of layer 1 versus layer 2 remedies, right? So for example, if the problem is people's funds getting stuck, then one solution is to lobby Ethereum community political actors, which basically means node operators, exchanges, miners, developers, whoever, to adopt weaker immutability norms and, for example, be open to, as one possible concrete step, be open to a one-time fork that undoes a whole bunch of stuck funds at the time when we move Ethereum 1.0 into the Ethereum 2.0 system. Another way to try to mitigate this that's more forward-looking is to lobby the developers of Solidity or Viper to add a feature into their programming language that basically says that if a particular contract has not been has not had money leaving it for 4 years and it still has money inside of it, then there exists some DAO that automatically gains control of the ability to take funds out. So what are the trade-offs between these kind of lower-level solutions versus of punting the problem up to higher layers?
Well, I mean, it sounds like the second one is more like a prevention than a solution. Mm-hmm. Like if your funds are already stuck, it's not going to help.
True.
And I mean, prevention is better than a cure if you can manage it, mm-hmm. But you're not always so lucky. Mm-hmm. And I think, you know, I mean, I take your point that at the end of the day, if it's impossible because of essentially the natural realities of software upgrades in blockchains to move away from an immutability culture, then I think we won't. But I think we have to first change our philosophy and then try to make the change. Because if we're not really earnest in our attempt to use blockchain governance to deal with disputes more elegantly, or at least more with more consciousness than we're doing today, then I don't think we're going to actually give it a real shot. So I mean, I think we need to try to explore the space of like what is possible to do with blockchain governance to deal with disputes that arise because of blockchain governance. And I think, you know, I think the philosophy is like the first thing as opposed to the individual ad hoc decisions, although the DAO was a good start.
Well, Vitalik, you brought up something about layer 1 versus layer 2 solutions, and you know, there's been a lot of talk about, you know, which one is more important, or do they both need to be in place for people to actually trust the blockchain and for mass adoption to occur? What are your thoughts on that?
Like, do layer 1 and layer 2 solutions both need to be in
correct long term?
Like, I use the words layer 1 and layer 2 here in a kind of very broad and abstract way, which basically where layer 1 is like solving something by adding either features or, in this case, norms to the operation of a base layer protocol, whereas layer 2 is more like there exists this thing that's built on that anyone just comes in and builds, and that's a way to do it, and people can just kind of opt into that and they want to, if they want to. There's definitely a lot of interesting trade-offs between layer 1 solutions and layer 2 solutions. Like, I, for example, definitely have an intuition that, like, where possible, higher layers are better because they allow kind of experimentation and progress to kind of happen more easily, and they reduce the load that kind of lower level political processes need to deal with. But at the same time, there are cases where like it's just because of the specifics of the situation, it's not concretely possible to achieve something on layer 2. So even like scalable data availability is one example. And so the solution you come up with by kind of hooking something together at layer 2 is just way more clunky and difficult than just doing a layer 1 thing and making it work well. You know, it's case specific.
Yeah, I mean, I more or less agree, although I think that like the cases where layer 1 is just strictly dominates layer 2 are so much that we need to just like focus and invest on getting this political governance process right and making sure that we have like a nice monolithic layer 1 that takes all the responsibilities that it's most suited to take, you know, despite the development headaches that might entail.
Mm-hmm. So I mean, let's look out like 20 years when I guess you both will be like in your 30s. And what like, so everybody in this audience and watching this on live stream, like, how will blockchain have actually changed their lives? Give me like a few examples of what you can see, you know, down the road.
Well, I mean, for one thing, I think it's completely not deterministic. Like, I don't think it's like clear today what this is, how the blockchain is going to impact people's lives. I think there's a bunch of different cases, right? I think there's like this really bad sad face case where like everyone's local legal systems decide they can't deal with this and they just ban all public blockchains. And then we live in a kind of private blockchain world where people only live inside like private blockchains that are protected with legal arrangements. I think that's like one world. I think there's another world where we have a massive liberational effect where blockchain is super empowering for many, many people around the world to do things that currently they're not allowed to do or they're not able to do within their legal and political spheres. And I think, you know, that really is, there's this like legal and political battle that's going to play out over years that is going to determine this outcome. Yeah.
Yeah, and like even outside of legal considerations, there's still the question of like in just how many areas and in what areas will blockchains turn out to be useful enough to justify the costs of figuring your way out around the new technology and switching to them. So like they've definitely gotten to the point where their like blockchain-based systems are useful enough for a lot of financial things. But there are other areas that people are getting excited about, like using blockchains for like account recovery and key revocation, for like, storing certificates on the blockchain, identity-related things, and this kind of big long tail list.
But hopefully people don't notice that, right? Hopefully it's like...
Yeah, exactly. I mean, like in the long term, I hope that people view blockchains kind of this as a different kind of cryptography. Like, you know, you have cryptography to prove that that some message was signed by someone. You can check a blockchain to prove that some message wasn't signed by someone. So, or at least a message of a certain type wasn't published in some particular case. And it's like a tool, and it might not even make sense for systems that exist today to kind of drop everything and move over to the tool, but if you're building something new, then I think there's a lot of people even today that just see the blockchain as, or a blockchain as a natural place to put some parts of the infrastructure they're building.
Yeah, I mean, even if every major jurisdictions bans the use of public blockchains, I think we'll still see blockchains proliferate everywhere where we see consensus protocols or where consensus protocols are useful. Mm-hmm. I think blockchain and blockchain-like consensus protocols are just more efficient consensus protocols.
And if you look down and you see this potential disintermediation, talk about decentralized, and name it, Facebook, eBay, decentralized banking, which kind of Bitcoin started it off. Where do you see like disintermediation? Do you see these corporations lasting? Do you see them becoming a participant in the ecosystem? Like how would you see this kind of evolving out?
Sorry, how do see corporations evolve?
Yeah, in other words, the decentralized, let's say Facebook. Do you see that happening, or do you see Facebook coming out with its own coin, really continuing to dominate?
Decentralized X is probably not the right frame for a lot of these things. It's like saying that like if you were like 30 years ago and you asked like what would dominate the internet, and your answer would be like internet-based newspapers. Like sometimes like okay, fine, you have internet-based bookstores and they work well, but there's a lot of cases where the model that makes sense with new technologies like just looks different from the model that makes sense using older technologies. And so I think the kinds of approaches that at least interest me more personally are ones that look kind of more further down to the kind of fundamental principles of like what it is that people wants to do, and like how concretely would you build a thing that solves those problems from the ground up. And I mean, you'll probably call it a blockchain, you'll call it a DAO, you'll call it whatever, but within those things, there's just such a large design space.
Yeah, and it's also getting bigger. So like over time, our capacity to do things with protocol as opposed to corporation gets better. Today, we're not that good at doing all that much with protocol as opposed to corporation, but we can do a lot of things. Mm-hmm. And we can do a lot more post-Bitcoin and post-Ethereum than we could have before that. So somehow protocol as an organizational force and as opposed to corporation is going to, I think, become more and more powerful and important over time. What exactly we're going to be able to replace with protocol, like which exact corporations are we going to want to and feasibly find that we can replace with a protocol, is yet to be seen.
Yeah, it's going to be fascinating to see how that plays out. And kind of wrapping up, and a lot of people have asked me to ask you, like, what are your daily lives like? I know you're both digital nomads. You know, do you only have hotel keys? Like, do you own, like, do you have a house? Do you have a dog? Like, what's your daily life like, and how many days do you travel? Like,
yeah, I got my little dog here.
Oh, geez, V. I don't know. Day to day, I try to do a few hours of research every day. Mm-hmm. Try to do some communications and not leave too many people hanging for too long. I try to take care of myself. I travel around. I try to get enough rest.
That's so similar to my life. What a coincidence.
Yeah. But definitely, I think that the cryptocurrency space has changed my lifestyle. You know, before I did have a home. Now I don't. And it's cool in some ways, but the jet lag is the worst part.
Yeah, well, the crypto community is happy to be your home for both of you, and you know, I'm speaking, I think, for a lot of people. We're really grateful for everything that you've done, and then you picking up and helping, and both of you, the advances that you guys have made. You know, just in wrapping up, is there like, you know, one thing that is like, you would say like it's most hopeful that you're like that keeps you going on a day-to-day basis?
Just seeing the progress of the technology with every week, and also especially seeing people increasingly start to come up with and implement like very real and useful things, like things that would actually significantly improve my experience with, I mean, both the crypto space and kind of the world outside of the crypto space. You know, like it feels like just we're every year getting closer to this turning point where blockchain-based stuff is like actually something that improves our lives in the present even more than it is a kind of hope for the future. And that's like actually seeing that progress happen is always great.
Yeah, totally. I love to see tech progress, and but it keeps me up at night because I know that people will abuse the tech, and so I also am really heartened a lot by progress in blockchain governance and crypto law and all the discussion that we see around the legal and political and governance issues in blockchain. I really love to see that mature and progress, and it gives me a lot of hope that we're going to create something that's good for the world instead of something that just creates a lot of headache and heartache. Because I think there's no question that the technology can do a lot of good for individuals. There's a lot of good for people who use it of their own, like, well-informed consent. but I think there's a lot of potential for things to go badly. And I'm, as much as you wanted something hopeful, I'm hopeful that we'll prevent things from going badly.
I want to thank both of you, and we're hoping that the next 5 years brings as many fruitful developments out of this partnership than the last 5 did. Thank you very much.